So we're going to do what we call show and tell, where basically people show the various robots that they have been working on to everybody. So let's start with who wants to go first?
Can we get a show of hands who has a robot tonight that they would like to show, just to get a feel for how much time we need?
Okay.
Okay.
So
I'm going to mic you up when you come up here.
yeah. So let's start bringing people up there. Would you be willing to go first?
Oh no, we didn't bring robots.
Okay.
I think this guy is a robot. I have a robot.
Okay.
Yeah.
Let's do that.
Bring the mic here then. He's not very mobile.
Okay. You can. Everybody turn their head towards.
Very cool.
Pull it in.
Yeah.
That's very kind. Hello. My name is Mark. His name is Maxwell. He's a android humanoid robot torso. His head is operated by 5 servos, 2 to move the head, 2 to move the eyes, 1 to move the jaw, which is open right now. Right now he's running a face recognition program using OpenCV, so whenever he sees someone looking at him like this, he lights up his eyes and he opens his mouth like, oh, somebody's looking at me, and then he attempts to keep you in center and frame, which unfortunately he's not a very fast computer, so he does it at about 4 hertz, so he's got a fairly slow follow rate. Don't you guys? Yes, that's his latest thing. He also, for a long time, had some animatronic features, so you could puppet the head with the joystick and type in arbitrary dialogue, and he does real-time lip sync. Unfortunately, he's not very loud, so it's not much of a demo for that. I mainly wanted to show off the face recognition thing I've been working on right now. I've been working on him for 15 years. So he's, it's been very slow and very incremental development, no doubt. He's running a PC, it's Windows. The face recognition program is written in something called processing, which is a very approachable programming environment. It was written a number of years ago for artists to do experiments with 3D graphics and sound and make interactive programs. And it has a way to bring in OpenCV so you can mess around with face recognition and do various things. And let's see what else. The wood parts are all laser cut. The face I sculpted. The face I shaped in my kitchen oven. It's plastic. And that's about it. Thank you very much.
Very good. Okay. What's the name of that robot? Zybot. Zybot's coming on up.
That's his name.
Okay. Let's bring her all up. Bring her up. While they're bringing the robot up here, I just want to let people know that all of these books over here are free. Whatever doesn't get picked up is probably going to wind up in the recycle bin. In addition, somebody has a Dell laptop here that doesn't work, but maybe if you're clever, you can make it work. So again, if it doesn't get picked up, it's probably whoever brought it needs to take it away, because we don't want to leave our garbage here at Google. Okay, ready?
Yeah, I think so. Okay. This is our robot Zybot, and we're going to try to pick up this little bottle here with our arm and hand. And this is the kind of newest version of several humanoids we made. And this one's being so far the best, and a lot smoother than the other ones.
Didn't I see that at the car show last week?
Yeah, it's getting popular. And we're starting to get a lot of use out of it to test the motors. The drive system's been tested for quite a while by Cam, who we basically took the design from. And then the arm drives are linear. There you go.
Operator. It's driver. Oh. Of course, you know I don't got a lot of practice there. There we
There you go. And what we did is we bought this material called Great Grip. And it's a flexible substance that really does grip doorknobs and other things real well. And it just allows us to really pick it up really good. It just...
now the question is...
Can you put it back?
Well, I can put it down.
The hand still needs a little bit of work, so sometimes it jams opening. And we have a new design we're testing.
It won't open because it's stuck. But we do, one other thing we did want to show.
Yeah, it's the weight capacity. So, goes a little bit. I got to get it open a little bit. Okay, so this bottle is full of water.
It's about 2 pounds.
It weighs about 2 pounds when out. So it picks it up really well, and with a little more control, we think we can get just a little bit more weight out of it. And
It's about as far as
it's still a little rough, but it was a pretty big accomplishment for us. The last one only lifted up 1 pound. So this one, we put the motor closer to the direct drive, and then we have it come from underneath instead of a top. And it gave us a little more torque, so it worked out pretty good.
And the other thing that we were able to do is we got the Adreno on there.
Yeah,
For all the people that have been trying forever, we got the light to actually flicker, so.
A lot of people helped us with this, but they, this is the Adreno run, the Blink program for the, with the Ross. Hold on, where is it?
See?
There we go. That was a big compliment. It took us a year to do, actually, to get the software on the computer.
And for those that work with it, they
and thanks for everyone to help with that. About 10, 15 people actually helped us get that to work. So we're pretty happy with it. In another couple months, it should be all done.
Right on. Thanks, guys.
Thank you very much. Okay, I see some people staying here. What I'd like you to do is come over here, and grab some chairs, and relocate the chairs over there. Okay, Osmond, will you go next?
Maybe one before me, and I'll turn mine on.
Okay. Let's see. Are you ready, Alan? Over there. So everybody face Alan over there. Just grab a chair, whatever you see. Okay. Hello? Okay, that's great.
Hi, I'm Alan Fitterman, and since the question has come up a couple of times in various projects, how do you actually control power? So I have a little power control based on a MOSFET. So for anyone under 12, can tell me what MOSFET stands for? Someone under 12 who knows what MOSFET stands for? Anyone? All right, anyone under 15? 16, 17, 50. All right, MOSFET, metal oxide semiconductor field effect transistor. Okay. Whoa. So that's PhD is good for something. Besides pushing brooms and flipping burgers. Anyway, so the way you need to think about a MOSFET, as you look at it, it'll say GDS. What's GDS? GDS, G stands for gate, D stands for drain, S stands for source. So think of it as a water tower with the water coming in the top as a source, the drain as where the plug for the water coming out is, and the gate as the valve that turns it on. So anyway, I have a little Arduino that sends a square wave that hits the gate. So if I don't know if people can see the light, I can control it in 9 intervals from 1 to full bright. And just as I can control the light bulb, I also control the motor.
No, it's instead.
So that's, as a gear motor, that's spinning at its full rate, and that's spinning at its slowest rate, and that's spinning at an intermediate rate. So basically what we're doing is we're driving a gate with a square wave, and because it's turning on, it's basically controlling the brightness by turning the switch on very quickly. So people make the mistake, oh, I want to slow my motor, I have a 12-volt motor, I'll put 6 volts to it to make it run half as fast, and that does not work. Thank you.
Okay, the next person that's going to demo is Osmond. Where's Osmond go? There you go. Wiring yourself up.
Just wait till the end.
All right, so this is a robot that I demonstrated about 9 months ago, and I just recently brought it out because in 3 months, who knows what event is coming up. Robo Games, exactly. So if any of you are interested in robots but have never been to Robo Games, it's a wonderful place because there's competitions from everything from the BattleBots to Robo Magellan, which is an outdoor contest. And my interest is in balancing robots. So this robot here competed last year. And basically, it's a two-wheel balancing robot. And ultimately, it's going to be autonomous, but just to test it and debug it, I have a little remote control. So this is just a PlayStation remote, and you can do it around, turn it around. So this is running this has got a Panda board on it. It's running Linux, and there you go. So there's actually a balancing robot race at Robo Games, and hopefully this guy will be ready to compete again. So I wanted to show you one other thing. So this is actually version 4 of this particular robot. It's acrylic and has some battle scars. So the next version is actually going to be made out of aluminum. So this is the beginning of it, the frame, and hopefully in a couple months it'll actually be balancing. So there you go.
Okay, very good. Okay, we're going to do Hercules next. Hercules is a little heavy, so let's let people pull it up on the table. This is a 2-person robot. 1, 2, 3, yay! Let's wire you out.
Okay. Okay, so can you hear me? Maybe put it over here. You stay back. Can you hear me? Okay. So this is Hercules. It's a differential drive robot. We're doing this project out of the Hacker Dojo. So come join us on Saturday at 1:30 to work with this and other robots that we have. What we have here, like I said, a differential drive robot. The real-time system is just an Arduino. The main system is a Raspberry Pi running ROS. We've got ROS Groovy running on this one. We've also been experimenting with visual recognition. So late last night, I won't demonstrate it here, but late last night we had face following from the robot. We have a series of 12 challenges that we're trying to do, starting from the very easy, just basic motor control, all the way out to considerably harder. We're going to be doing those over the next few months. We call it the 12 Tasks of Hercules. Thank you very much.
Let's see who's next in terms of a robot. We're going to do this one? Let's do it. Sure.
Tim, can you help me carry some?
And there's still a few chairs left here, so people without chairs should come here and grab some of these chairs. There's one here, there's one here. Sorry.
That's good. Mic on you. That, you're also put that in your pocket. Is that all you did?
Okay.
Testing. Testing. Hello? Testing. It's not working.
Make sure that it's on.
Hello? Hello?
Yeah, it's working.
Testing. Okay. This is the KFC bot, and this is the microcontroller. And right now it is not working. Oh, actually it is. I just changed the battery. Okay. This is the Arduino board. What's this one called, Jay? One on top. Right here, right? What's this one called?
Shield.
Arduino shield, and then this is all the Lego guys from Star Wars, like some of the robots, and these are servos from Parallax. This is a strainer and some corks and water bottle caps. These are paint sticks and lights. This came in a kit. And that here's the battery pack and the Buzz Lightyear that I'm going to turn on. And this will follow the light with a flashlight. And now I'm going to show it. Can I show it right here?
Put it on the table up there.
Yeah, I'll let that on the table.
Right.
The other table.
Here, right here.
Make sure.
You can pretty much steer it.
You go from one table to the other, you'll have page one.
You keep going, you gotta let it keep turning, it might make it. Need to make it higher. All right, good.
There it is.
Very good.
Hey, Wayne?
Just tell them about that one of them.
Just pick one of them.
Okay, and this robot right here can have a sensor here, so when I run into thing, that's on the bottom, and sensor here, so for the top, so when I run into anything, I'm going to show it.
Hard to see, turn it up a little.
No, it's not.
It's pretty creepy.
It's amazing how real it looks now. Yeah.
Robot bug.
Now it's on. Okay. Let's see.
Very good. Thank you.
Thank you.
Okay.
Help me, Jay.
So our next robot is coming here.
Oh, wait.
Slider left.
Hi. Anyone hear me? Okay, cool. Okay, so this is Kybernets. It's Robo Magellan robot that UC Merced Robotics Society built last year, although I seem to be the only one working on it anymore. So basically, it's we took a Traxxas Emax RC truck and then just built a platform on top of it. So made just 2 Arduinos and a BeagleBoard. Decided not to run ROS because it was having some performance issues at the Robo Games last year. So basically it was like lagging on motions and things. So if like it drive past a GPS coordinate, it wouldn't realize it for like 2 seconds, 3 seconds later, and then crash. But so this year it's actually done. It does Robo Magellan now. So I guess the next 3 months are going to be tuning. Hope it works better. So the demo that I had running on it. So I don't really want to drive it around in here. It's kind of big. But so it tries to find north. Maybe if you notice the wheels. So like rotate it past north. So now that I just found out they actually do a tabletop challenge at Robo Games, it's kind of a personal project. So I don't know if Robotics Connection sells the Stinger chassis anymore, but so I got a BeagleBone over the summer, and I was just playing around with it and decided I'd just look through what I had kind of in the boxes, like in my house, and just threw something together. So hopefully I'll be doing tabletop with this at Robo Games. So BeagleBone, like USB web camera. I've just been the main work that I've been doing with it is just like Linux kernel development, because as far as real-time hardware running on Linux, the BeagleBone has a lot of I/O. So I keep thinking of it as like the Arduino of the BeagleBoard world. But if you're trying to like using devices like encoders and doing motor control on it, it's not very responsive and it lags the CPU a lot just to try to do it in user space. So we actually got the PID algorithm that runs the motors actually implemented as a Linux kernel driver. So
very good. Okay. Yes, you're next. Can't be cutting off our speaker.
Sorry, Andrew. These smart tables kind of anxious.
Okay.
Right over here.
Go ahead and stand behind the table here. Very good.
Oh, okay. So this is my TableBot robot. So it's running Linux and demand peripherals baseboard here. So basically what the TableBot challenge is, it's an HPRC challenge that's basically the beginnings of TableBot soccer. So it has several stages. One is just to kind of roam around a table, not fall off. 2 is to find a block and push it off the table. And 3 is to find a block and push it into a goal. So last time I demoed this robot, I was doing number 1. So now I've gotten enough to phase 2. So there are 2 things it basically does. Is 1, it scans around it, and if it finds something that's less than 150 millimeters from its ultrasonic sensor here, then it drives forward until it pushes it off the edge. And then number 2 is if it doesn't find something, then it just kind of wanders around the table doing phase 1 until it finds something, and then it pushes it off the table.
Andrew, what's the name of your robot?
Oh, I don't know.
Kind of scary on the table.
Okay. So what it's trying to do now is it's doing the first part, which is just finding a block, but what it seems to be doing is finding me instead. So let's try that. And so number 2 is just for the sake of time, I'm just gonna have it wander around and then put a block in front of it and have it.
Did you say that's a Panda board?
Yeah, this is a Panda board. This is Bob Smith. He comes to the HBRC sometimes. This is his baseboard, and it basically, this is an FPGA, and it's doing I/O. Yeah. So this is just roaming around. Found someone again, I think.
Yeah. You gotta give it a name, dude. Looks like Edson.
Okay, so it looks like one of the problems that I've been having is that there seems to be like some sort of ultrasonic like turn on the lights when people walk in detector. And what that's doing is it's messing with my ping sensor and making it think that there's something like -1 millimeters from the sensor, which is kind of a problem, but yeah. Still kind of fine-tuning it, yeah.
This is Locomotion, the smart table. I've demoed it about 3 or 4 times. I actually have essence of map here. Basically, it's a stock XV11 with a IBM computer Velcro to it. Thank you, John and John. With Ubuntu and ROS, I'm running the Nito node. The thing new this month is I'm using my smartphone, Android, as the hotspot. So there was a lot less configuration when I showed up. Usually there's a mad rush to configure all the IP addresses and so forth. There was still a configuration to do, but 30–40% less. So without any further ado, I shall attempt the TableBot challenge with a full-scale robot here. Please stop, thank you. Little angle and tap. What can possibly go? Don't try this at home, kids. We're trained professionals. Stop. All right, that's it.
Okay.
So this is basically like a modified version of the robot I showed last month. Yeah. So first of all, everything on this robot except the Arduino is powered by this new bigger 12 volt 18 amp hour battery that I got. Is lead acid. So the Arduino is powered by a normal 5 volt battery. 9 volt battery. And so another big modification I made was by putting this Linksys webcam on it. So first we tried putting it on, but it required 1 amp, and we only had 1 regulator, and it didn't give the required wattage. So we decided to get a new one, and it gives a little higher wattage. So we decided to put that on, and it's only for the webcam. So we connected it and it worked. So right now, currently the webcam can only be seen when it's in my house because it's connected to the router in our house. And then the sensors are an 3 IR sensors, 1, 2, and 3, and then there's a ping sensor up here. And then they're powered via this breadboard over here. From this 12 volt battery is giving it to the breadboard via there's a regulator right there. And then these motors are directly from here. And I hope so this currently just does like surveillance in our house. And for navigation, it has like a left turning tendency. So it'll go like that. So like whenever it hits a wall, it'll just adjust. And then we have some other like procedures for like when it gets stuck and stuff like that using the ping sensor. And then next is, so currently this is still a work in progress that me and my dad are working on. So currently just made out of wood, and it has a lot of sharp edges, so it's kind of like annoying when your foot gets under it and stuff. So I hope to like replace this wooden stuff with a sturdier material. So that would be really good, and I hope to use it like in other places than just my home. So yeah, and I'm hoping to get another name for it. So.
What's the name now?
Currently it's Bugs Bunny. Okay. Yeah. So let me just show you how it moves. Yeah. So right now it just has that left turning tendency. And let me just put my shoe there. So it just adjusts like that. And if it sees something, it'll just back off like that. If it sees something in the front, it'll turn around and it'll go straight. If it sees something, it'll turn. So it's basically how the main navigation system works. So yeah, that's Bugs Bunny.
Very good.
This is a little micro mouse robot that actually won a silver medal at Robo Games a few years ago. Now I'm just using it to play with things. And it is run by an Atmel microcontroller, and it has a few IR sensors and encoders and stuff. So last month I was showing how I drive it around with ROS and the ROS visual tools like Arviz. And this week I wanted to show how I drive it around with Arviz running on an Android tablet, but right now it is not working anymore for some reason. I will give it another try. Nope. Okay, then I will just show how it runs from here. So I'm clicking in a kind of a map to enter the coordinates where it should go, and it just goes there.
So do you have a map on your computer?
I could have. The tool supports a map, but it's kind of a 3D view of all the space. Yeah, so that's it for this one. Another thing that I actually wanted to show today was live teleoperation of a walking biped robot on another continent, but I only have a HDMI output that I cannot hook to this. I can show you later on my screen, so...
Okay.
Yeah, thanks.
Very good. Boris is next. Now, I have Boris, that one. Any more robots after these two? Okay. There's one back here? Okay. So you'll be after, you'll be kind of Taylor's chart.
Do you happen to need this?
No.
Okay, I'll put it back.
Okay. I don't like wearing things, but hello, everybody. My name is Boris, and I have two robots. One is my following Robo Magellan robot, which soon would be a Robo Magellan robot, and it's almost done, I guess. Anyway, this is Anito, and I wrote an article about it recently for Servo magazine. It's going to be in the March issue. So,
Yay!
If anyone wants to read it, subscribe to Servo. I'm not commercializing. Anyway, so this Nito robot, if anyone doesn't know what it is, it's a vacuuming robot made by Nito Robotics. Has a huge variety of sensors, including a LiDAR. It's a laser scanner that takes distances off objects, if anyone doesn't know. So the tabletop challenge, as somebody else explained here, I'm not going to explain. So it does the second one. I need something to push off the table. Something taller than 4 inches. I guess that thing would work. So I wrote an article how to use it as a table topper. Anyway, so it scans for an object and it just goes for it and stops because it has these IR sensors on the bottom. And I wrote the code for that, and it's running ROS, the ROS Nito node, and then I'm just taking topics. I configured the, I modified the Nito node to take the information off those other sensors.
Last time you did it from scratch, didn't you?
Yeah, I did it from scratch. It kind of sucked. So
okay. Well, it worked. It was fantastic.
Yeah, now it's better. Okay.
Let's see.
That's the starting sound.
So your table cleaning product.
Absolutely. Okay, I hope this works. Wait, I'm going to turn this around so it doesn't seem fake. There, awesome. Now, this should do it. No. I hate when that happens.
That's exciting.
The side sensor senses.
Do it again. Do it again.
And it stops the robot. Okay. Wait.
Don't be proud. Orient it right.
Let me do this again.
At least you didn't accomplish phase 4.
I never did.
We'll see about that.
Overconfident.
Never say never.
Exactly. Okay. Whatever. Yeah, I have to do this faster. Go, do it. Do this. If I put a... Whatever, just go. Just do it. I'm not gonna... No, go for it. Yes. Yeah.
Very good.
Let's turn it on.
Okay.
Thank
You're next.
Testing.
I got it.
So last time I did a robot that used ROS and Arduino, and it used, and then I had a plan to expand it so I can have multiple robots communicating with each other. I don't actually have any robots, but Tony told me about this thing called the Amazon EC2 microinstance. It's like a free cloud that you can get from Amazon, and I got it to run Ubuntu and ROS Forte, and my original plan was to make something to demo that. But as it turns out, it runs excruciatingly slow over the VPN, and I have to reset up VPN if I wanted to use it here. So instead, I just made a simple like a mind simulator, so like a mind detecting robot simulator. this turtle sim thing that comes with Ross. Hopefully you guys in the back can see. So this each one of the turtles on it is one Ross node, and I made a command node. So if I type yes for detected mine, then the robots go to the center and then they all die because they found a mine. So it's like a very simple mine simulator, mine detecting robot simulator.
Okay, thank you very much. You're gonna put it on. Okay.
Cool. Hi everyone. My name is Mark. This is David. We have a couple other guys here. We're from Brew Robotics. This is the first time we've actually come to one of these things, but we weren't even planning on giving a demo, but they dragged us up here. So this is Double. It's a telepresence robot that works with your iPad. So you just slide an iPad in on top, connect over Bluetooth, and you can drive around remotely from anywhere in the world. So David is going to call in. I put it on the floor so it doesn't fall off, but it's a self-balancing robot like a Segway, and it has these little little kickstand legs that come out the bottom. So right now it's self-balancing. The kickstand legs just went out, so I can push it. Sort of like what every roboticist has to do at some point in their life, right? Build a balancing robot. We've managed to get it pretty stable at this point. We're still working on the firmware, still working on getting this out there, but we're taking pre-orders now. We're assembling these here in Sunnyvale. So,
Good.
You can buy them on our website, pre-order. It's $2,000. Bring your own iPad, snap it in the top. It's got a telescoping pole, so you can go up to about standing height, and you can go down to sitting height. So it's pretty natural to have a conversation with people. That's pretty much it.
Very good.
For like video teleconferencing?
Yeah, exactly. So you can call in. You can just be at home and visit your office if you were sick one day, or if a doctor wants to visit more patients or something like that. You can go to multiple hospitals with it. Real estate agents want to use it for putting them in homes so that people can just visit the home without having to go there. There's a lot of different.
Teachers can teach online.
Yeah, our kids can call in when they can't make it to school.
Yeah, cool.
One in the back and then camp. One in the back.
Did you bother putting a real-time controller in there, or you just have an iPad do everything?
The iPad does a lot, but there's actually a PIC32 on here. Yeah, there's no operating system down below, but iPad does most of the work.
Does it have drop sensors to keep it from falling off stairs?
No, you can actually drive it upstairs. So there's no sensors actually in here at all, and it's sort of yeah, there's a accelerometer, gyro, and all that obviously, but there's no actual distance.
It'll know it's falling, but
you'll see it falling. Yeah.
How does it deal with things like Wi-Fi handoff if you're going down a hallway and you have to switch access points?
Yeah, if you have multiple access points that are all the same network, then it'll just hand it off just like iPad does, which is kind of cool. It works extremely well with like Airport Express or Airport, just because it's an Apple product, but pretty much anything that just has, if you're just repeating the signal, then it's fine. Yes?
Have you tried it with industrial or enterprise grade roaming? Like with a Cisco or a Ubiquiti.
Like a Cisco router?
Like a Cisco wireless that has it's like a controller-based wireless with dumb access points.
Yeah, I can't say we've actually tried it on that just yet.
The Ubiquiti Centro S.
No, we haven't tried it on that one. Maybe we just tried it kind of on what typical offices have, but
Typical office might have.
Yeah, we haven't tried it on that specific one.
Okay.
It also works on 4G too, so if it hops off of Wi-Fi, it'll just pick up on 4G.
I have to start cutting off questions. We're running out of time.
Well, we'll stick around and you guys.
So they're not going to leave. So just catch them afterwards.
Thanks, everyone.
I think we can talk about this. Thank you very much. How many people here built the club bot about 2 years ago? Or Simon, you need to raise your hand. You did it, didn't you?
No, I did.
You what?
I didn't.
You did not. Okay. Nobody here? Okay, well, anyhow. 2 years ago, we had a robot that we built for the people who wanted to get started in robotics here at the club. And I'm proposing that we try again this year. This is a quick prototype that I did of the robot. It uses an Arduino as the processor, just like last year's. And then it uses something called Brew Robotics gear motors. The reason why we use those is because we can get a back shaft on them to do odometry on. The ultimate goal of this robot is to be both a tabletop challenge robot, but with enough expandability so that we can put something like a Raspberry Pi on there and run ROS on it. The goal would be that we basically have a robot that takes us from ground zero up to running ROS without breaking the bank. I think this can be done for about $150 without too much troubles. So I'd actually like to find out if anybody would like to participate in another club robot thing again this year. Camp's raising his hand. That person. So if you folks could catch.
Well, what's required of us to join that? What do you?
We don't know yet, but we'll figure it out. Okay.
Sure, we'll do it.
Yeah, I mean, it's just like, are you interested?
Yeah, definitely.
Okay. So if you're interested, at the end of this meeting, could you find me, and we'll quickly try and arrange a time to talk a little bit more. Okay. So I was Cam. I don't know your name back there. Todd? Kyle. Okay. And I can't. Angelica. Okay. You folks can find me after the talk. We can talk for a couple minutes.
Wait, I have one announcement before that.
Okay.
So speaking of ROS on ARM, there was a few people here who were going to meet after the meeting to talk about ROS, specifically ROS on ARM. In case you haven't met up with each other yet, meet over here right after Wayne breaks us.
Yeah.
And I'll introduce everybody.
Okay. So I'm going to turn this one off. Okay. Now what we're going to do is we're going to take a few-minute break and let Andra finish setting up, and then our speaker, Andra, will be giving a talk on Silicon Valley Robotics. So about 5 minutes break, okay? Thank you very much.